So our topic is chemical reactions. Chemical reactions. This should be the first topic, although because the only reason why this is not the first topic is because we are looking at the basics. We wanted you to know how to write the chemical formula first and to understand the concept of atoms and all that and the elements. So now at this stage, we talk about chemical reactions. So the statement is scientists use chemical equations to describe reactions they observe in the lab and in nature. So a scientist will present something that is happening in the lab or a natural phenomenon. It's explained as a chemical reaction. So what do chemical reactions give us? So they give us the means to, one, summarize reactions. So it's easier to understand what is really going on if you have the chemical reaction there. That this and this are reacting and they are forming that. So to display the substances that are reacting, you show which ones are reacting and show the products. You also show that when this and this react, the result is this. And then indicate the amounts of the component substances in a reaction. Meaning in that case now, we also use reactions to help us to understand the relationships, stoichiometric relationships there. So that's the reason why reactions are important. So chemical reactions always involve change. So that's the case. Atoms, molecules, or ions rearrange to form different substances. So that's how it is. Even you guys, like when you are in a relationship, there should be chemistry, meaning there should be a rearrangement. You change some things. If the person that you meet does not change anything about you, it means there's something wrong. So that's why we say there was no chemistry. So what is that chemistry? It changes your reasoning, it changes your understanding of things because the love is too strong. So chemistry and love are alike. So some of these reactions occur in a spectacular manner, meaning when you see them, like this thermite reaction, they are very beautiful to look at. There will be some kind of explosion. So in this case, aluminium will react with iron 3 oxide. And then what you see will be a spectacular scenario there. So the reactants are aluminium and iron 3 oxide. So actually what happens here, this one is called the displacement reaction. We'll come and talk about them in the next lesson. Aluminum goes and displaces the iron, and the iron moves out and the aluminum comes. So you get iron and aluminum oxide. So that's called a displacement reaction. They were just appreciating the person who made this reaction, this spectacular reaction. This is called the thermite process, where aluminum displaces iron in its oxide. So then we write something there for a reaction. We say during reactions, chemical bonds are broken and new bonds are formed. The reactants and products may be present as solid, liquids, gases, or in solution. So I'm sure you've seen state symbols when you are in grade 12, where you are saying S in brackets, a small letter S in brackets, a small letter L in brackets, a small letter G in brackets, and AQ in brackets, standing for the word aqueous. So that showed that that was in a water solution. So when we say solutions in this case for chemical reactions, solutions are water solutions. Because water, if you remember so, is a universal solvent. So in chemical reactions, atoms are neither created nor destroyed. All atoms present in the reactants must also be present in the products. So tafirwa hiyo, rearranged. So meaning you can't say you had say carbon on the reactant side, and then on the products there's no carbon. You have a reaction. So atoms are conserved, they are not lost there. So you must understand that. So the next case is just to describe. I'm sure this point is it's angering to you, where guys we are telling you that we separate reactants and products with an arrow. Simwaliana imubenefaya okutira. What does it think for tuaba? Kusaza mkutoa pati chemical reaction ati arrow iba pakati. Kale moishi befu. So reactants and products, the difference is that they always be an arrow like that. Then when you balance equations, you balance them by adding coefficients in front, meaning you don't come and change something down there. No, you always add the coefficients in front, meaning these molecules or formula units will always be intact the way they were presented before before you balanced it. So only by when you balance, you put a number, a whole number, mostly in that case. It's also possible, since this book was emphasizing that you use all numbers, which is the best. To use all numbers is the best. But if you're reading your book, you will find number fractions. Kusada fati E2 itapati. E2 tapati. Elo babika pa half na pa half. It's very possible. Don't throw the book, just know your maths. Such that when you want to get back all numbers, you multiply everything by 2, then the 2's will come back, then the half and the 2, when they multiply, it becomes 1. So no. Then conditions are sometimes placed on top of the arrow. So conditions that are desired for reaction to take place. Reactions do not just take place, guys. They should be accepted conditions of temperature. So meaning sometimes for a reaction to take place, you must heat it to a certain temperature. So to show that you are heating, the delta is what you use to show that you are heating. Sometimes we also put catalysts on top there to show they're not part of this, they're just rearranging the atoms. So the delta means heat is added to the reaction, like that. So remember, then the states, you put them as subscripts, like that. That's how you put the states. So the things that are in reactions, to the under, symbols, a plus means this and this are added, reacting with. So somebody CH4 plus O2 means CH4 reacting with O2. Then the arrow means yields or produces. The S means solid state, L liquid state. So for L, that's what you put on bromine, mercury, water itself, and other liquid compounds. So you put L if it's at room temperature, that is. If it's at room temperature, because sometimes if the temperature is so high, you may find that even whatever is liquid has vaporized. So those are things. As we said, G is gaseous state for gases. AQ is aqueous, meaning in this thing that is reacting is dissolved in water. Then the delta means heat addition. So it means you have added the heat. So the next point is that mass is conserved in chemical reactions, meaning the mass on the reactants is also equal to the mass on the product. Meaning if they tell you to say 5 grams of A reacts with 10 grams of B, and then you form C and D. If the amount of C produced is say 8 grams, what is the amount of D? No, it's law of conservation of mass. It means they're telling you that the total mass on the reactant must also be the total mass on the product. So to get the other stuff that you're looking for, you just subtract from the total mass that is there. So this is how you work this thing out. Sorry guys, a bit exhausted. Mbutaika sana. Nachilami butaikira. That's why I even added the Zoom very late because I was running from where I was. So writing and balancing equations, we'll balance them by inspection. So remember guys, that balancing by inspection, even if someone doesn't teach you, you can actually know how to balance by inspection. So that's how it is. So what we'll be doing most of the times, we'll be given a word equation, then we'll isolate the formulas and the symbols from that word equation, then write the unbalanced equation. Then we'll count the numbers of atoms that are there to say there is one of mercury on each side, but the oxygen has to be balanced because there's one on one side and two on the other side. So how do you balance? Since there's one here, you factor the factor we put on top, so you put a 2 there. Once you put that 2 there, you realize that the mercury becomes unbalanced, though the oxygen is what? Balanced. So you just put another 2 there. So when you just put the 2 there, it means it is what? Balanced. So this is how you go about these things. So if you've seen so well, guys, a O2, O2, oxygen exists as a diatomic molecule. Oxygen exists as a diatomic molecule. So muri equation tabakalako bati no oxygen which is diatomic. They'll just write it as oxygen. So you must remember those ones: hydrogen, nitrogen, oxygen, fluorine, chlorine, and noble gases. Oh no, hydrogen, oxygen, nambuka and gases, hydrogen, nitrogen, oxygen, and all the halogens who exist as diatomic molecules. So bakala tupera fefati oxygen, hydrogen. It's your job as a chemist to say this hydrogen is H2. It's your job as a chemist to know how to balance and how to know. So there are quite a number of examples here, because these things, the more you practice them, the more you perfect your craft. So before we say anything, it's that this balancing by inspection is not only balancing that is there. Sometimes you find redox equations, which are very difficult to do. And for those, we will need a set of rules. So the last point that is there is that when you balance these things, they must always be in their lowest terms, not to multiply by a factor in B. Because your favorite number is 4, everything always, when you balance it, must always be in the lowest terms. 2, 2, 1, not 4, 4, 2, which is correct, but we'll go for that one. Techno, what's going on, Marsha Mikey? Techno, Spark 4. Okay. Let's switch off the mics because your friends say they get very bad feedback. Switch off your mics, sir. Okay. Technology. Okay, so we move on. We'll say magnesium plus oxygen gives us magnesium oxide. So remember, oxygen is diatomic. So we write Mg plus O2 gives us MgO. This is the formula for magnesium oxide. If you remember, Mg was 2 plus, O was 2 minus. So it just gives us MgO. So you find that magnesium and magnesium are balanced. It's similar to the one we're doing, except in this case, the products here are video. But it's the same thing that you do. So you see that this one is balanced, but then the oxygen needs to be balanced. So you put a 2 there, and you will balance our oxygen. But then you also realize that the magnesium is not balanced, so you put a 2 in front of the magnesium. So it's Mg plus O2 gives us 2 MgO. I'm emphasizing again why oxygen, by oxygen, but O2. It exists in nature as a diatomic molecule. Hydrogen of fire. If someone mentioned hydrogen is produced, then that hydrogen must be diatomic. Not kuluba, guys, friends, bachibusa, not kuba lost. Naminomba. Then I've already said when we do this balancing and talk about types of reactions, then we'll do the redox, which is also very simple. So this is the case. The next one is methane plus oxygen. So the reaction, when you just hear the word combustion, undergoes combustion means it is reacting with oxygen. If it burns in air, then it's reacting with what? Oxygen. So you say CH4 plus O2 gives us CO2 plus H2 plus O. There you focus on the carbon because it's appearing once, and the hydrogen is also just appearing once. The oxygen, the other side balance, as you are balancing in film, wasanga tinambya problems now, so bakale wa balance. So carbon is already balanced, meaning we skip from carbon. If it wasn't, it's one we're supposed to start with. Then hydrogen, there are 4 there, then there's 2 there. So what factor do we put? We put a 2 there. And here have a 4. So what is 2 plus 2? You have a 4. So if this is 4, to make this 4 also, kubika 2 pantange. So you have written the balanced equation. So that's the way it is. Fyalinaka guys, if fyalinaka. Potassium chlorate, the same thing. Potassium chlorate, you have to perfect the name of potassium chlorate because even bromate, okay, bromate meaning kwalba na iodate. Na iodate. Fluorate can be there, but but you can find fluorate because these are halogens. So meaning any halogen can go there. Because iodate na diumvapo na bromate na chlorate. I've seen those. So this one, when you balance, you see that the KCl are balanced in both cases. The only thing that's not balanced is the oxygen. There's 3 there, there's 2 there. So if there's 2 and 3, you switch and make these coefficients. So this 2 goes there and multiplies everything. So that when you multiply 2 times 3, you get 6. This 3 also goes in front of there. So that when you multiply this 1 times 2, it also gives you 6. So when you put a 2 there, then wabika 3 up. The only thing that will remain, since there's a 2 in front of these 2, you also just put a 2 there. So then you would have found your answer. Kesia, you have been highlighted because now got a question. Kesia, do you have any question? Mayoba Kesia.
No, sir, I don't have any question.
Padi highlighted, bracket. Okay, so, but you understanding?
No. Yes.
Are you understanding?
Oh, wow. Yes, sir.
Too much. No, guys. Yeah, also too much. Therefore, to the file, first understand too much. So the next question, to balance hydrogen nitrate, silver nitrate, hydrogen sulfide. If gases first, you can even be given these two. This one, this is decomposition. This is decomposition. That's this type of reaction. Then for this one is double displacement. Why? Because these ones are exchanging partners. Like the silver will now go with sulfur, and the hydrogen will go with the NO3. So that's how it is. At this stage, our skill is not to know to predict the reaction, the products, but I can just tell that that's what we'll be talking about on Monday. So that's the case. That's if you want to be registering in school. I'm sure you are eager. So when you have AgNO3, H2S, giving you Ag2S plus HNO3. So what you realize is that the NO3 is already balanced. The NO3 is already balanced. The S is also already balanced. But then the Ag is not balanced. So what you do is you put these two wasayibika pantan sharp. So ngwabika two pantan sharp, you also realize that this one gets affected. So you also put a 2 pantan sharp. So you just put those two. 2 upper, number 2. The rest will find that they are already balanced. When you're balancing the friends, you find you also balance the other stuff that's there. Then the next in aluminum oxide with the aluminum hydroxide with the sulfuric acid. So what you get, remember the valency of aluminum is 3, so Al3 plus, then in SO2 minus. So in the exchange, it gives you Al2 SO3 plus H2O. So balanced. So these are things. Bromine, AI is next. Bromine is next, because for bromine, it's the same as that one. Bromine is very tricky one because if you want, you can even use fractions for bromine. You can use fractions, although it's very encouraging that you put all numbers. So you will see that carbon is not balanced. Hydrogen is also not balanced. So kwambira poine carbon, hydrogen. Why are you starting with these ones? They are the ones which are appearing once on both sides. So you can actually deal with them just singularly. So what you will see, say there is, since this is C4 and you qualify carbon, you put a 4 in front there. 4H2, 4CO2. Then since this one is H10, you put 5H2O. So what is 4 times 2? 8. 8 plus 5, 13. So actually we can put 13 over 2 pantange. Why 13 over 2? Half of 13. Why half of the total number of oxygens there? Because when you multiply 13 over 2, it's only to give you 13. Okay, the 2 and the 2 cancel. So then you don't want to leave the reaction, the equation balanced like that. Now a balancer, fraction. So when you see over 2, you put a 2 in front of everything you multiply. Then to give us this 2CH4, 2C4 plus 2C4 H10 plus 13 O2 will give us 8 CO2 plus 10 H2O. So those are the things. The other statements, guys, are that for us in chemistry, we want to use this balancing to benefit us now. So when you balance these scenarios, it means we don't really look at how many atoms are there, especially the molecules and the moles. The molecules and the moles, the beauty with them is that when you just cut molecules somewhere, you remain with more. So that's how it is. So when you have 2H2 plus O2 giving you 2H2O, what that means is that you're going to have 2 molecules of hydrogen, 2 H2 to be plus 1 molecule of oxygen, giving us 2 molecules of H2O. So that's the case. So now when you work this thing out, it's the same thing. These ones are also used now as mole ratios. So it's 2 moles hydrogen, 1 mole oxygen. Where's the one coming from? There's one there, giving you 2 moles water. So if someone asks you what is the mole ratio there, you say it's 2 to 1 to 2. That's how it is. So you can further expand this and actually talk about it in terms of mass. It means 2 times 1 plus 16 times 2, which is 32. 2 times 1 is 2 times 2 is 4. So what is 4 plus 32? 36. Then what is 2 times 18? Because the molar mass of water is 18. So it's also 36. So it means in this case, the more the mass ratios are balancing. What do you get the mass ratios? You multiply the coefficients by the molar mass to know how much is reacting per mole. You multiply times the molar mass. So this is the case. Then the next thing, guys, propane, just emphasizing the same thing. Propane with oxygen, giving you carbon dioxide and water. So it's 1 molecule plus 5 molecules, giving you 3 molecules plus 4 molecules. So the moles here now, we don't emphasize that no, if we balance some moles. The one that should balance is the mass. You should make sure that the masses our team are balanced. So that's the case. So in propane, in one propane, there's 3 carbons, 8 hydrogen. This one is 5 oxygens. This one is 3 CO2, which is 3 atoms, 3 atoms of carbon, 6 atoms of oxygen. Then in Gawaisapa, you also get the same thing. To get the number of atoms, you must multiply this times 2. So I add a step here. So that's the thing. So guys, these things are very simple. Your practice was encouraging. Now mufumia nchitoza naparika practice nimi pero kuboko. Empirical version. Aluminum plus oxygen giving you aluminum oxide. Jose na mchaya. This is the case. Even the magnesium oxide, hydroxide plus phosphoric acid. You've done very splendidly. Keep up, Jose. The same with Jacqueline. Jacqueline is one of the most hardworking people in our class. Keep up, Jacqueline. So what you've written there is very correct. So that's the thing. So I can work except ngatuwabika poaro eltosa share. Make sure you use advanced editor. So go to where it says advanced editor. So that if you put an arrow, it can also show. So what you've done is very correct. So this is a case. So what you get as the total mass is that much. So you have done very splendidly. You must keep up. So this was Jacqueline. Terrific work. Mapalo, terrific work. But Jose. Na mukasa papena tata ba Jose. Hydrogen plus chlorine. Jose, you are the one who got the first one correct. So you must reason like that, Jose. Don't just focus on hydrogen, on oxygen at a diatomic. Even hydrogen should be H2 plus Cl2. Chimona ba Stefania na bina babigrefe ka hydrogen kamona ka chlorine kamu. Remember that chlorine and like hydrogen, I stated them. You should be reading them. Those ones exist as diatomic molecules. So instead of just writing hydrogen kamu, you should write it as H2 plus Cl2, giving us 2 HCl. So like this one, if so. I think Jacqueline has done exactly what we wanted. Mule kopera kono kopera vile stabane. So not see, my kula kopera munandi. No kum kopera first up. Not that was for amaka ya kum kopera wakwata ida nishtabuli test. No. Apapena you should see. This is what Jacqueline has done. So it's H2 plus Cl2. Why H2 plus Cl2? Because hydrogen and chlorine exist as diatomic molecules. Mr. Tembosa.
So how's practice one correct? On this one, Gashinga and Joseph Ranganani.
Bakamba, mulikuisa mule mutaveni, mulesula economy. Joseph. Kuli chongo cha uko nishe. Chefia niko. Wa Steve. What Joseph Mulenga Wutawangombe has done is correct. Why? Because aluminum is singular, but oxygen exists as O2. So that's what he did, Al plus O2. Then you remember that Al is 3 plus. then O is 2 minus. So you just change the partners, so it will give you Al2 or 3. So if you add Stilomones Joseph Nadi. Was Stephen couldn't fit a tongue which you could it be Malaysia economy? But Joseph, was Stephen? But Junior. Continue. But we used to have Sana economy. Now, for Shani, it's a class use English. Okay. But now, this is correct. Who else has a question?
Sir, I still think it's not correct.
Oh, you want him to balance it?
Yes, it's not balanced. Isn't the question asking for balancing of it?
Oh, yeah. He must balance. Jose, go and balance your equation. But this preliminary round is okay. But go and balance. I think Stephen at this point also. Thank you very much, Stephen, for the data. So you go and balance. So the first ones you balance are the oxygen and the oxygen you balance because there's a 2 there and a 3. So the first thing you put is a 3 there, then you also put a 2 there. So to balance the oxygen with a factor by factoring. Then what will remain there, apakusa bikapo 4. So it will be 4 Al plus 3 O2 giving us 2 Al2 or 3. So this is how it should go. Thank you very much, Mr. Tembosa. Guys, key and skill sana is to remember which ones are diatomic. Which ones are diatomic. So go and reason like that. Especially if badembe was Stefania. Vengi badembe. So do not forget. So nefi we don't accept. We just write as H2 plus Cl2 giving us 2 HCl. So the only thing that you balance need the last. Guys, these things work very well just by inspection. Does anyone want to say something? Marva Stefania. Okay. Matthews. Are we okay? Luxion. Okay. So since you are quiet, I just want us to focus on the same thing that I've emphasized. Remember hydrogen, oxygen, nitrogen, and all the halogens. When they are just mentioned, when you just see a Cl, you Cl2. F, you F2. O, you O2. Either in oxygen to rumble oxygen. That's how oxygen exists as stable. When we don't use those, it means ozone, we know ozone is O3. That's all. But when there's just a mention of hydrogen reacts, then your job is to remember that hydrogen will react as H2. So those are things. Even iodine, you write I2. Remember to always look up those ones which exist as diatomic molecules. Then the rest you balance by inspection. You write the equations and then you balance them. You make sure when you're balancing, this is by inspection. Ngatwambali oxygen kula basina abantu bamwita but yali wamaya wamasana. But balamwita abantu tetwafuna kwefu. So these are the scenarios. Otherwise, that is the case. So remember, guys, if you do not balance an equation, it's preliminary. When you ask the question in stoichiometry and then you don't balance the equation, just that balancing would have cost you all the marks. even when the question is 20 good marks. So this skill of balancing, improve it. Make sure you can balance these simple one-step equations, so that the only things that you'll be struggling with are the redox. Keep up working hard. I can't wait, guys. It's good news that schools are opening, but let's continue to keep guard. When they say the economy has been opened, it doesn't mean they've declared corona that it's free. Please. So make sure the onseka mask umweni